economy, meaning loan demand comes back, that would be very positive for the group, no doubt about it.
What about M&A, Gerard?
Hello, everyone. Hello and welcome. It's wonderful to be with you all today here at the International Convention Centre in Sydney. And I'd also like to extend a very warm welcome today to our online viewers, wherever you are in the world, because of course we are live streaming this event through CNBC's social media channels. Now, as you've just heard, we are here to talk about enabling sustainability through technology, and what an incredible partnership that is, especially when you look at the latest data, which essentially shows that even as recently as last year, 2024, global greenhouse gas emissions was still creeping upwards, which is not the news that we want or need right now. So an incredibly important discussion that we are going to be having today. Now, we're going to be joined by CNBC's Mandy Drury and her amazing panel. They're going to be coming up in just a little bit. But before we hear from them, I have the great pleasure in introducing to you our first guest today. So, ladies and gentlemen, please help me give a very warm welcome to Colette Munro. Colette is, of course, the President of the Pacific for Schneider Electric.
Thanks, Arlie. Thank you, Arlie.
Welcome. Now, Colette, you have this amazing position right now. You are right smack bang in this intersection of innovation, technology, sustainability.
Absolutely.
I think this is a really key question for your experience and where you are at. What do you think of how we are progressing, not just of where we are right now, but also the speed at which we're getting there?
Yeah, it's a good question. Thank you. So we heard a little bit from Manesh about how we're going, but let me just go a little bit further on that. So in New Zealand, we're at 88% of our grid coming from renewables. So in New Zealand, very, very high, because they have a very high base of hydro, but they were able to increase their hydro and solar and wind last year. Here in Australia, it's a little bit different. We're at 39.4%. So, you know, we're making some progress. In fact, we made almost 10% progress last year in getting more renewables into our grid. So that's for 1 year quite a big step, and that's obviously the kinds of steps we need to keep making, and even a little bit more. We need to go a bit faster. But it's the first year that the renewables were higher than the black coal. So it's something to celebrate that we got to that point, but now we need to go even faster on that journey and adopt all of this technology to do that.
Well, let's talk a little bit about that technology and digitisation. And of course, at this point, you cannot go past the role of AI. Now, AI, as you'd all be aware, is a really interesting paradox. It has enabled us to take these huge leaps forward on one side, but it comes with some significant risks, in particular energy demand. So how do we make sure we're not weighed down by those risks and we continue to let AI really propel us forward?
Yeah, AI has this amazing potential, and I think we've heard that for a little while. So now we want to know, what are the real applications? How do we use it for sustainability? So I'll give you a couple of examples. One example actually is with the South Australian Power Network and ARENA, which is the Australian Renewable Energy Agency. And together with them, we're working at the moment to put a new solution into 500 homes. So it includes solar, battery and the EV charging in the home, and then it has a home energy management system which has an AI engine in that. And what it's able to do then is connect to the grid, connect to all of those devices in the home, and then understand how you want to use those devices in your home. When do you want to charge your car, all those things, and make those decisions for us, which will then lower our energy usage and lower our bills. So it's a fantastic project and very exciting to see the results coming out of that. I think there's another really good use case that Schneider's been involved with in the US. So in the US, we've been working with one of the largest installers of EV charging solutions. And together we've created an AI-based application that allows those installers to go into the home, take a photo of the distribution board in the home, and from that photo, quickly assess what is the capacity in the power network within that home, and therefore be able to streamline that process more accurate and more reliably actually to what needs to be done so that I can install EV charger or a battery or some other device into my home. So they're two really good examples of where AI is having an impact.
And how quickly does that come to our region?
Yeah, we're working on it. It's coming. For sure.
So when we talk about innovation, of course, and the energy transition as a whole, you know, you look back in history and energy transitions have taken decades, years and years, if not decades. How do we ensure that this particular one does not take that long?
Yeah, we don't have that time.
No, we don't have.
I think we've seen, what needs to happen. So the good news is the technology is already here, right? It's about adopting that technology and changing the way we work and the digitisation that you just heard about. They're all really key to what we need to do to start gaining more momentum and going a bit faster, not just on the renewables, but also on that energy efficiency side and bringing down how much energy we actually need to use. Because 27% of that renewables is being wasted today in Australia. So we've increased our renewables, but we're wasting 27% of it. So we need to work out how to improve the efficiency, make sure that every megawatt is going to something productive.
You know, this is particularly relevant, I think, this discussion for the Australian audience, in that we have the highest take-up of rooftop solar, globally, which is incredible. But we still have that wastage that you're talking about. So when it comes to renewables and the movement there, what are you most excited about when it comes to innovation? And again, you talked about efficiency as well as demand.
Yeah.
You know, from that side of it, there's some incredible things happening in terms of batteries and microgrids. And tell us a little bit about that.
Yeah, lots happening in batteries and microgrids. So so a few comments on that. I think, let's start with the grid scale. So on the supply side, we're seeing a tremendous amount of new grid scale batteries going through, funding stages, design stages, and now a lot of construction. By 2027, we can expect, if everything goes to plan, about 16.8 gigawatts of that battery energy storage now being available in the grid. So that would be fantastic for our national energy market to be able to use that. And gain more, not just energy efficiency, but resilience for our network, which is what we all want. We want to keep the lights on. So that's pretty powerful. Then if you come down to community batteries have become a really big thing. So instead of putting an individual battery in each home, you can have a battery for, say, 100 homes. So that battery might be a bit smaller. Maybe it's 3, 5, maybe up to 10 megawatts, but it's a battery that can feed that community, and that's at the edge of the grid, and that's where we start connecting then between the grid side and the consumer of that power, or what we say behind the meter. So that's where we can start having this interaction. Lots of projects going on in that space, more money being put into that, more funds available from the government in that space. So we see a lot of that community battery, very, very exciting. And then on the other side, we see data centres being more efficient, putting in more cooling technology so that they can cool all of those, servers after servers that we're putting in to feed the AI machine. They are actually producing more heat. So therefore we need this cooling capability and a lot of new technology there and really driving that efficiency. And then finally, just efficiency within our buildings, within our manufacturing environment. So putting solar on the roof, using low-cost heating, low-cost cooling, low-energy heating, low-energy cooling, and then the adoption of EVs.
Yeah.
So,
which is a really interesting one, the adoption of EVs, because it's been a much slower take-up, I think, particularly in this region, than many had expected. This is about hearts and minds, is it not? Yeah. Changing the hearts and minds.
Yeah, absolutely. So a couple of things there. I think, first of all, you're absolutely right. We've been a little bit slow. So by 2027, we're expecting 1 million EVs in Australia and about 80,000 in New Zealand. That means we need more charging because we actually don't have enough charging infrastructure in Australia or New Zealand. The New Zealand government's actually committed a target, I think it's 10,000 by 2030 of more charging units in New Zealand. So that's a good commitment from their government. So we will see those things try and help. But as you said, it's about choosing to want to be in an EV. And very interesting project actually it's called the Race to 2030, and Schneider's involved, the University of Technology here in Sydney, and a number of other groups are involved. And they're going out and really researching not just that what do early adopters want, but actually what does the broad community in Australia want out of EVs, and what's holding them back, more importantly. And what's really interesting, there was things coming up in that research like, the fine red dust of WA, will an EV handle that dust? And, how does an EV fit with my outdoor lifestyle? And so I think there's a lot of these broad community questions that we'll need to work through to get those hearts and minds. And then the same thing happens for us even we've rolled out a large program called Smart Factories. So in our own factories, working with our staff in those factories to say, what ideas have you got? Here's the target we want to get to. Here's the areas we want to focus on. What ideas do you have? What would you like to trial? And then we kind of let them lead a bit more and try the things that they have in mind. And that way we find you get bigger buy-in. They really love it. They take real ownership of that. We've rolled out EVs in our fleet as well, and the same thing happened. There was some hesitation, but once we got them in the cars, once they were sharing with each other all the new things, all the range anxiety went away. And now it's, everyone's fighting to get in the EVs. So it's, once you get there, once you get through that hearts and minds piece, people are actually really accepting and enjoying the new technology and what it brings.
Well, it's interesting, and this is particularly relevant to yourself and me, of course. For those of you who don't know, we are both from Queensland. We're both from Brisbane and have just been through the X-cyclone. Alfred, it would have been really handy to have some of that battery technology so we weren't hearing all the generators around the suburbs as all of our power went out. So the sooner that you could organise that, the better. Thank you.
Yeah. No, and that's really interesting because, we're all obviously there thinking about, what does this mean? Do I now have to go and buy a diesel generator? And we saw people starting to look at vehicle to load. So your electric vehicle can actually, charge some devices in your home. And there were some people trying that out. And then also, we see the future here as vehicle to grid, because at the end of the day, the battery in your EV is at least 4 times and probably sometimes up to 10 times bigger than the battery you're going to put in your home. So you're going to have this battery anyway for a lot of people sitting in their garage or their carport. So, it's close to the home, and in the future we'll be able to do that. And new standards have come out in Australia so that will become the case. And manufacturers of the EVs are implementing those standards. Manufacturers of the charging, including ourselves, have implemented those standards. And then the grid is working out how to operate with those standards. So once we get those 3 players, we'll be able to really harness the power of everything in the EV. That's super exciting for us.
It is very, very exciting. Now, Colette, just before we go, I wanted to touch on the mandatory climate-related financial disclosures that the government's put in place essentially since the start of this year. Yeah. As a director yourself, and I'm sure we've got many directors in the room today, how much is that helping or is it hindering? I mean, how are you finding these disclosures?
Yeah, actually, it's a big education. I think even for Schneider Electric, where we measure a lot of things already, really looking at that standard and understanding what we had to do and how to comply. There are civil penalties if you don't comply, so it does make all us directors put a lot of focus onto that. And we've brought in people to help from our own consulting group and from others to give us all the advice. But it makes you get more granular. It makes you bring all the data together from different parts of your organisation. And it really does make you look at your organisation. What are the threats of climate events? Things like Alfred, we had to shut down our distribution centre for a couple of days. What are the threats? But then also, what are the opportunities here? How does climate change and how that changes where we live and how we work? How is that going to, where are the new business opportunities as well? And so you have to look at both sides, and you have to then set, baseline where you are, set a plan for where you're going, and then be able to action that. And that's being tracked from real financials. So it makes you be more granular, more focused on that data, bring the data together, make sure you're measuring all that data, and then what decisions are you going to make based on that? So it's really insightful. I found it very insightful.
Yeah. Amazing. Look, we are out of time. Thank you so much for joining us today. Ladies and gentlemen, please help me thank Colette Munro.
Thank you so much, Rolly.
Now, we are going to be joined by CNBC's amazing Mandy Drury in just a short time with her panel. But first, please take a moment to enjoy this short video, which is going to set the scene.
The digital economy is transforming faster than ever. Governments and companies across the globe are investing in green technologies to help achieve their climate targets. But can technologies drive sustainability fast enough to achieve net zero by 2050?
In order to hit any target in sustainability, you have to focus on the technology. because the technology is the major driver for the sustainability.
An EY report revealed 55% of businesses surveyed currently investing in IoT technology believe it's improving their sustainability forecasting. Many organizations are also looking to emerging technologies such as AI and quantum computing as a solution, while others feel the tools required to achieve net zero emissions are yet to be fully developed.
We're going to see entirely new industries emerge, especially in the climate space. When I look at carbon removal, carbon capture and storage, sustainable aviation fuel, long-duration battery storage, the companies that unlock the secrets to those innovations, they will be the household names of the year 2050.
How can organizations overcome the challenges of adopting new technology to build sustainable supply chains and stay ahead in the energy transition?
A lot of people are putting money in a whole variety of diversified sources, and it takes time to mount the amount of capital we need to get the transition done.
Innovation is helping to reshape industries, revolutionize energy, and redefine sustainability. But can we utilize and scale these innovations in time to secure a net zero future?
We've seen so many advances in technology that we feel like there are a lot of places where we actually can achieve 24/7 carbon-free emissions. And so in that case, it's not about getting to net zero, it's about getting to zero.
From policy shifts to technological breakthroughs, the momentum for a sustainable future is accelerating. Welcome to CNBC's IoT, powering the digital economy debate as we focus on enabling sustainability through technology.
Hello everyone, fantastic to see you all out there. My name is Mandy Drury from CNBC, and wasn't that a great conversation between Oriel and Colette? And it really set the scene for what we're about to talk about, because we've brought together three thought leaders from very different sectors, but they're both, all three of them are driving innovation and sustainability, and that of course is why we're here today. So let me introduce to you, we have Professor Veena Sahajwalla from the UNSW Smart Centre, also known, by the way, as the Waste Queen, sometimes also called the Recycling Revolutionary. There are a few other monikers out there. We've also got here, sitting in the middle, we've got Olivia West, otherwise known as Liv, Head of Sustainability at HP for the Americas, APAC and Japan. And you're, Liv, helping HP achieve something which I think is absolutely amazing, and I really hope you can get there. You want HP to be the world's most sustainable company. We also have here Scott Brown, Managing Director of ASX-listed Pure Hydrogen. And you're, Scott, leading the charge in zero-emission technology for the heavy vehicle industry. We're thinking things like trucks, right? And also developing a hydrogen ecosystem. So let's get straight to it, shall we? Veena, I would love you to set the scene for us, because you were inspired by walking the streets as a child in Mumbai, and you saw that nothing was wasted. Everything was reused and repurposed.
That's right. Yes. No, thank you. Thank you for that question, Mandy, because I think nothing's more exciting. It's like being in Disneyland when you're a little kid and you're walking through the streets of Mumbai and you're seeing all this amazing action. And I think it's something about, I guess, waste and recycling. You know, whether you're in Mumbai or here in Sydney or anywhere else in the world, I think we often tend to stop and ask that question, you know, where is all this stuff going? So when somebody tells you something's headed for recycling, you know, that automatic curiosity kind of comes in and you go, all right, what are we actually making with this? And I think to me, that's really how fundamentally the journey of what we're doing here in Australia, the Smart Centre at UNSW, has taken shape. We're really privileged at UNSW, you know, that we get to explore not only, of course, the science and doing the science, very important. We've pioneered micro recycling science that allows us to actually do recycling in a way that's never been done before.
And when you talk about where does it all go, where does it all end up? I mean, think about old rubber tires and how many millions of those are produced every single year, and they just end up in landfill. So you're using rubber tires to make green steel.
Yes, this is something.
Pioneered this.
Oh, yes, indeed. And thank you for bringing that up. I have to narrate the story of a conversation literally just last week. This company in Denmark basically is saying to us, hey, we've been supplying to a customer in Europe rubber materials to make green steel. And of course, as you can imagine, their motivation in contacting us was, we've been doing it for a few years now. We're using your technology. Can we do more? And I think to me, that's really fascinating because I think fundamentally it goes to the heart of what micro-recycling is all about. Mm-hmm. We're not seeing it as converting into more tires. What we are really talking about is how do we liberate hydrogen molecules, clean hydrogen molecules from those tires inside steelmaking. So it's very much about let's generate hydrogen, let's enable the process to become green by accessing those hydrogen molecules.
And I love the circularity of this, right? Because waste is both the problem and the solution.
Indeed.
So Liv, let me get to you, because HP's goal is to achieve 75% circularity in products and packaging by 2030. How do you get there?
Yeah, thanks, Mandy. Great question. At HP, sustainability is part of what we do. It's been part of the company DNA for over 85 years, and we're committed to delivering innovative solutions and services for our customers that help them lower their carbon footprint. And circularity is certainly one of those ways that we can support our customers by lowering carbon footprint, reusing metals, plastics, use fishing nets in the design of the keycaps underneath the in the keyboards. But circularity is just one of the many ways that we're driving innovation within the design for sustainability and the products and services that we're bringing to life. Not only that, but helping our customers reduce their carbon footprint with our innovative carbon neutral services as well.
And you're also using data, and this is a really big topic. I know that Colette and Ariel broached this subject of using AI and data. You're using data as well to help achieve that, aren't you?
Yeah, absolutely. AI is driving a lot of innovation within our own supply chain, using that to cut out waste in the services that we're delivering to our customers, but also helping our customers to understand their own footprint of the devices, so real-time data on the PCs, understanding energy consumption, but also helping not only that, but just driving efficiency, data and productivity, and reducing energy consumption of the device itself.
Lovely, and we'll unpack the AI and data story in just a moment's time in more detail. But Scott, on the technology, transportation, this is an area that really is very promising, isn't it, when it comes to hydrogen, a very promising application. And it's not just trucks. It's things like shipping, it's aviation, because there are some challenges when it comes to battery electrification for these heavy-duty vehicles and transportation. This is the incredible thing. I believe that a hydrogen fuel cell produces no pollution. Water is the only byproduct. So why is it still so niche?
Look, I think, well, thanks for the question. It's very much at its infancy. There has been really good steps in the last 12 months or so. We've now got a hydrogen truck, both a garbage truck that's now in delivery in Adelaide. So that's going to be used for council pickup. That's a hydrogen-powered truck. One of the great things about it, not only is it no pollution, there's no diesel pollution, which can be detrimental to your health if you breathe it in, but also, it's much lower noise. So something like a garbage truck where typically it's early morning, you'll hear less noise.
You hear it barreling down the street at 6 o'clock in the morning.
Correct. But look, all sorts of applications we can put fuel cells. Fuel cells are really efficient. They're twice as efficient as an internal combustion engine in terms of getting the energy out of that from hydrogen compared to, say, diesel. So we see lots of different applications. Lots of people are working on it. and we're very proud to be part of that new cycle. One of the trucks that we are implementing for Victorian Government, Barwon Water, are getting a prime mover we call the Taurus. That will be available. We're about to do the handover in April.
So what do you need to see then from the government and from regulators to be able to support this industry? Because so many of the green hydrogen pipeline projects have been shelved, just haven't been a starter. What do you need to really kickstart this sector?
I think there needs to be a much more understanding from all tiers of government, so from local to state to federal government. A lot of the regulations are not in place, and a lot of the regulators, unfortunately, because they regard it as new technology, they're very gun-shy about approving things in a timely manner, and so a lot of projects have been delayed because of approvals. Also, part of the thinking has been wrong. We've been trying to think about exporting, where instead we should be focused on supplying Australia and trying to make a local industry here before we start doing export.
That would be the practical thing to do. You're also focused very much on smaller scale projects that can scale up, right?
Correct.
The hydrogen being produced, because transportation of the hydrogen is one of the biggest challenges and obstacles to development so far. So the hydrogen needs to be produced close to where it's going to be used. Is that correct?
Absolutely. So one of the two disadvantages of hydrogen is storage and also transportation. So if you produce hydrogen on site, and have a back-to-base operation, that's an ideal. So using the garbage truck example, where you have a fleet of garbage trucks go out, they come back, they can refuel on a site. That is probably a good use. Or the other one would be bus fleet, where again they go out and then come back and have it all self-contained. And the good thing is we also sell all equipment, refueling equipment, and also equipment to make hydrogen. So you can make it on a site, you can make it very small scale, start from a few trucks, and then scale up from there. So we think that's probably the way, rather than trying to build these mega plants from the get-go that are very capital intensive and approval-wise are going to take forever to get approved.
So, Veena, you're leveraging two layers of tech. There's the tech to, for example, find all the e-waste, the discarded devices. I mean, who here has been through, like 2 or 3 phones just in the last 10 years? I can certainly put my hand up there. Old batteries. I mean, there's so much stuff out there that we really should be reusing. So you're using the technology to turn that into things like manufacturing materials.
Yeah.
And then you're also harnessing the next layer of tech, the data, to identify where those bits of e-waste and devices and whatever are. So that
look,
you can get it.
Absolutely. And that's the important thing, You don't know what you don't know, right? I mean, so if you're not aware of the fact that in my battery, for example, I've got these really valuable metals. So yes, you could have lithium-ion batteries that may be a rich source of cobalt. You might have nickel metal hydride batteries where you've got nickel. And then, of course, in hard drives, you've got rare earths. So why would you not go, well, you know what, how much of these devices and parts and components are going to come in to my warehouse? So if I'm somebody who is actually in the business of, managing that supply chain, you can actually go, I can keep track of what are some of these products coming in. Even better, if I know the value of what's embedded in these materials. So if I know that I can extract those important materials, I've now created a whole new business. Being part of that supply chain, enhancing sustainability in a way that it's not just about, oh gosh, it's a problem, so I need to find a way to dispose of it, but rather let's turn the whole business model upside down and go, well, it's not a problem if I know that the value of these metals is enormous. And this is the whole point, that a lot of these metals are also limited resources.
Yes.
So we're addressing that important sustainability issue of enabling access, making it a lot more environmentally friendly and lowering our carbon footprint.
And Scott's got something to say.
Yeah,
as well.
I was just going to say, one of the areas you mentioned earlier was tyres.
Yeah.
So, and look, one of the great things is people are looking at how to take something like that that's got a lot of energy content in it, and then turn it into, in our case, hydrogen, and to be able to use.
Absolutely. That's such a lovely point, isn't it, Scott? Because, I think what we're saying here, and that's why I was making that point about green steel, where hydrogen is a critical molecule that is required. But now imagine if you could liberate clean molecules of hydrogen by supplying through these kinds of technological advances. And yes, with our polymer injection technology, we're able to not only deliver that hydrogen, but actually demonstrate how would operations in the making of green steel work. So it's fundamentally challenging the traditional ways in which we can make these materials, which is pretty exciting.
It is very, very exciting. And Liv, you made the really pertinent point earlier that sustainability, and it's become a bit of a buzzword, hasn't it? Sustainability this, sustainability that. But what is sustainability exactly? It's not just about reducing waste and being environmentally friendly. It's about, from a business perspective, and your customers have to also think of the bottom line, because you can't be sustainable if you don't also show me the money. It's about reducing, it's about optimizing resources, it's about lowering their footprint, it's about better supply chains. So tell us what HP is doing with AI and data and tech to achieve that.
Thanks, Mandy. You summed it up really, really well, and some great points, both of you, around tech reuse and material reuse as well. Sorry, I'll just get you to repeat a little bit of the final bit of the question.
What you're doing in terms of leveraging AI and data to help HP's aspirations and also your customers' aspirations.
Yeah, Mandy, thank you. Data is really, really important. So not only, we're seeing an increase or, an introduction of sustainability regulation emerging of financial reporting and sustainability reporting no longer.
Can be very onerous.
Yes, a lot of data requirements if you look at European legislation and the Australian legislation that's coming in next year. So our customers need, practical solutions to understanding their own footprint. Not only at HP do we need to focus on reducing our footprint and harnessing AI for more predictability and waste reduction, less, visits, less waste parts in our supply chain, but enabling customers in real time. So, bringing AI to the device, the laptop itself, and building MPU into the device so that AI can be managed on the device itself, but also providing customers with real-time energy consumption and data so that they have the information they need to be able to meet those reporting requirements is really critical.
What if someone doesn't have a device? I know that sounds like a silly question, but there are global limitations, aren't there? Because we're all extremely privileged, and there are a lot of other countries that are extremely privileged, but there are countries that don't really have good and easy access to digital devices and internet access, the most basic, what we consider basic, like food and water these days. What are you doing on that front?
Yeah, absolutely. Access to tech, unfortunately, it currently depends on wealth and country location. But, even here in Australia and over the dish in New Zealand where I am, the digital divide still exists, which is extremely disappointing when we talk about the potential of these amazing technologies that you talk about on the stage today. And so to be able to power the future workforce, we need to have equitable access to digital technology for everyone to be able to thrive in that digital economy. So partnership is really important. Understanding the potential of unwanted, devices and how we can reuse and redistribute those, not just to other countries, but here in Australia and New Zealand. We partner with Deadly Science and have supported our customers to achieve their sustainability goals through the likes of partnering with KPMG on a donation for their Laptops for Lifelong Learning program, and in New Zealand introducing HP Regen, which is a device donation program for
That's really fantastic, isn't it? So let's get back to the issue of cost, right? Unfortunately, everything comes down to it. It's good to have a nice concept, but you've got to also to be able to commercialise it. Scott, fuel cells have been expensive, but the cost is coming down. And am I right in thinking you forecast the price will fall 90% 50% over the next 10 years. Why is that? And what are your other hopes in the next 10 to 15 years in terms of usage then, adoption?
Right. So, yeah, what you have is a lot of companies around the world have put in plants for fuel cells. So companies like Honda, Toyota, Hyundai, Cummins, and Ballard have all built out capacity in fuel cells. And if you look at the cost of a fuel cell, it's actually there's not a lot of material involved in it. A fuel cell looks like a PC, and you put it into in our case, a truck or a bus. So that's why already fuel cell prices have come down about 50% in the last 3 years. I think in time they will come down considerably as that more capacity comes online, and also there's more competition. There's also Chinese companies, a number of them, that are also build capacity. So the capacity will dictate that the prices will fall dramatically, and that's what we're forecasting.
You've also got a prototype of autonomous trucks.
Yeah, no, this is really cool. Just on, we did demonstrate it at the Brisbane Truck Show. It's a autonomous vehicle for particularly port operations. So we're talking to a couple of operators in Australia where you could simply drop a shipping container onto an autonomous vehicle, so the back of the trailer, and then it will take, using AI, it will take and park the shipping container in a designated spot. So we think that's a really interesting one. It's in prototype. We still need to do more work on it, but that has huge potential. Ultimately, we do think there will be autonomous driving for some of these commercial vehicles, both trucks and buses.
And of course, we need the whole ecosystem, the government regulations. We need the insurance companies to get on board. There's a lot more to that, but that's a different topic for a different day. We're not going to get onto that. Getting back to you, Veena, from going from proof of concept to proof of profit. It's all part of credibility for you, isn't it? And not just here in Australia, but on the world stage. You've got a bunch of patents right here in New South Wales, and you've also got some show and tell for something very exciting that you're doing.
Indeed. Such an important point you asked there, Mandy, really around the proof of concept. When does it actually become real? Yes, it's got to be able to get out of the lab. It's got to be piloted. It's got to ultimately get into the industrial application. But that critical important thing, how does it compare with traditional products? Is it going to be profitable? So it's not about saying, well, I'm making it because it's green. Actually, that should be the last thing. The first thing has to be profitability. Does it work? Is it showing the right performance? And when you have performance guarantees out of a product, whether it is about making metals or plastics, in all of our products that we're talking about here, whether it's machinery, equipment for IT, whether it's electronic devices, the important thing is, how do you actually make something from waste? Is it just about taking the same old? Absolutely not. What we have shown here, an example of what I did bring a bit of show and tell is, because right here in Sydney, we've actually, about to go live with our, it's been running quietly behind the scenes for a few months now. But this is made out of 100% waste plastics coming from all kinds of old printers. And you can imagine if these plastic filaments that, of course, one can go and buy, so you know what the market price is. But if you can make those now in a microfactory, which is where our tech comes in, and if you can make that so that you have performance guarantees, if this can now feed into a 3D printer, can you actually print a whole range of products? And this is where, the example that I brought in is a highly functioning clamp. Now you might go, okay, well, what's such a big deal about it? Well, imagine all the building and construction projects where you need clamps. And imagine if you had to wait for a long time to source these parts and components. But in contrast, you could literally talk to your local microfactory and say, can I make this at a competitive price and the right kind of performance. And this is where microfactory technologies have come in to really close the gap between what is seen as a waste on one hand, and then on the other hand, make something that is high performance, high tech, and competitively
So we're
priced.
closing the gap and we're closing the loop, which brings me to you, Liv, to finish things up. I feel like the role of a CSO, you know, a Chief Sustainability Officer, that's why we say CSO instead of the longer version. It's really evolving, isn't it? I mean, it used to be just like do more recycling, turn out the lights, and now it's very much part of the key C-suite and very much integral to the entire operations of a company. And yet, things like ESG has become a little bit of a dirty word over in the United States. How do you help yourselves and also your customers maintain the commitment to sustainability in what does seem to be a fairly dynamic and changing global policy and attitude environment?
Wow. Yeah, thank you for that final question there. I mean, we're just seeing across industry and across the globe, you know, I sit across a wide range of, you know, different geographies. The commitment to sustainability is still there, and it's, you know, starting to become a fast-moving train now with this global regulation coming in across Europe and in Australia next year. HP's vision for sustainability is aligned to our customers' requirements. You know, we see AI continuing to play a big role helping businesses reduce their energy. You know, we'll continue to commit to circularity, challenge accepted, to find new ways to do that here locally, but, you know, amazing. But I think really importantly, the access to technology should be, you know, a right, not a privilege, and that we will maintain our commitment to that so nobody's left behind.
Nobody's left behind. And I know I'm running out of time here and I might get smacked by the organisers, but I do have to just give you the last word on this one, Scott, because everyone's mind is going to be blown. My mind was blown when you told me this. Everybody talk, you know, activists, politicians, regulators, we all talk about green hydrogen, but there's actually a myriad of colours out there. There's emerald hydrogen, turquoise hydrogen,
Correct.
pink hydrogen, which is a very hot topic right now with nuclear.
Correct.
What does the future hold?
Oh, look, I think there's a whole range of different ways you can produce hydrogen, and people are just starting to come to that. I mean, we're just talking earlier about producing it from tyres, and that's very much emerald hydrogen, where you can take waste streams and convert it into something useful. So I see lots of different ways, and we shouldn't be blinkered into saying this is the only way to do it, because it's all about, as you mentioned earlier, show me the money, the lower the cost, and also getting the best environmental outcome you can possibly get. So.
And maybe there'll be some new colours we haven't even thought of.
I'm sure there will be. People will come up with different ways of doing it. Yeah.
Well, all three of you, thank you so much for what you're doing in this journey. And of course, every single thing that you're doing also helps save the planet for our future children and their generations beyond that. So thank you very much. Let's give a big round of applause for our panellists.
Thank you.
Engineering is not as boring and bland as people perceive it to be.